Solving linear and quadratic equations. A monomial is an algebraic expression consisting of only one term, for example, 3x, 7xy, and 4x squared. You can see that all these numbers only have one variable. The one that often confuses students is xy. Yes, x and y are different letters, leading most to believe that there are two variables involved, but it acts as a monomial because they are being multiplied. To add or subtract monomials, they must have the same variable. Simply add or subtract the coefficient while keeping the variable unchanged. For example, let's take a look at 12x plus 15x. Both have x as their only variable, so we simply add 12 and 15 to get 27x. Remember, the variable does not change. Only the coefficients in front of the variable change. Let's try 3x plus 4y minus 2x minus 3y add 10x. Remember, you can only add monomials that have the same variable. So in this case, we would add together the terms with x and add together the terms with y. So let's rewrite the equation as 3x minus 2x plus 10x plus 4y minus 3y. This simplifies to 11x plus y. And that will be our final answer, as we can't combine terms with different variables, which are x and y. To multiply monomials, you multiply the coefficients and the variables separately. For example, let's look at 10x times 4x. Since we multiply the coefficients and variables separately, we can rewrite this as 10 times 4 times x. This gets us 40 times x squared, which simplifies to 40x squared. A common mistake you'll see here is a student forgetting to multiply the x's together and getting an answer of 40x. And they will list 40x as an answer. Be careful, slow down, and take your time. These will be on the easier scale of questions, so you don't want to make the careless mistakes and miss out on easy points. Let's try another. 3x times 10y times 4x times 2y. Like we did when we were adding monomials, we'll want to separate the similar terms. So we'll rewrite this so the x's are together and the y's are together. So it'll look like this. 3x times 4x times 10y times 2y. This multiplies out to 12x squared times 20y squared. Then you can multiply the coefficients 12 times 20 to get 240x squared y squared. Dividing monomials works very much the same way. Now let's take a look at linear equations. Linear equations with one variable are the most basic equations you'll find on the GRE. To solve them, always isolate the variable. The way to do this is by performing the inverse operation. For example, x plus 10 equals 17. So we'll want to isolate x, and the way to do this is to perform the inverse operation, which in this case would be subtraction. So subtract 10 from each side of the equation, and we get x equals 7. One of the golden rules of algebra is, what you do to one side of the equation, you must do to the other side of the equation. There are multiple ways to solve linear equations. If you are uncomfortable with algebra, you can plug in the answer choices to solve using substitution. With a linear equation problem, where x represents the value of the answer, you can plug in every choice into the equation until you find the one that is correct. Let's take a look at an example. X plus 10 equals 17. The same problem we just solved. So instead of taking the time to operate on the problem, we can just plug in the answer choices and see which one works. Plugging in 4 gets us 14 equals 17, which isn't true. 9 gets us 19 equals 17, which isn't true. 5 gets us 15, which equals 17, which isn't true. And 7 gets us 17 equals 17, which is correct. So you can see how substitution can be a helpful strategy to solve linear equations. If you're ever unsure how to proceed on an algebra problem, substitution is a good lifeline to reach out to. Of course, the downside to substitution is that oftentimes it is more time-consuming than simply solving the problem through inverse operations. It is always your choice, but if you can solve through basic operations, that is a faster route. Let's get into quadratic equations. By definition, a quadratic equation is an equation that has a squared term as the term with the highest power. For example, x squared minus 5x equals negative 6. You can solve quadratic equations. Think of this as one step further than factoring. To solve, just set the equation equal to 0. This will require getting everything on one side of the equal sign. And ultimately, have you heard of this one before? Isolating the variable. So let's stick with our example. X squared minus 5x equals negative 6. Our first step to solving this is to move the 6 over with the other terms. To do this, we'll add 6 to both sides, so we can set the equation to 0. X squared minus 5x plus 6 equals 0. Now we can factor the equation. Remember, we're looking for two numbers that multiply together to produce 6, but also have the sum of negative 5. Let's look at the factors of 6. Remember, a negative number multiplied by a negative number produces a positive number, so negative 2 times negative 3 still nets us a positive 6, but their sum is negative 5. Those are our factors. So we'll have x minus 3 times x minus 2. Now we'll set each individual equation to 0 and solve through. X minus 3 equals 0 and x minus 2 equals 0. Add the 3 and add the 2 and we're left with x equals 3 and x equals 2. And those are our answers. You may see quadratic equation questions written in a different way, mainly in reverse. You should be able to work backwards from the solution to find the original quadratic equation. Let's take a look at an example. For which equation is x equal 1 and x equal 4 the solution? So let's work with this one in reverse. We'll subtract 1 and 4 back to the left side of the equal sign and get x minus 1 times x minus 4 equals 0. Now we can FOIL these two terms. Remember FOIL. First, x times x, outer, x times negative 4, inner, negative 1 times x, last, negative 1 times negative 4. So that leaves us with x squared minus 5x plus 4 equals 0. And that's our answer. Let's look at an example problem. Max has a collection of video games. If he subtracts 5 from the number of games in his collection and multiplies that result by 6, it would be the same as multiplying the total number of games in his collection by 3 and adding 75. How many total video games does Max have? Let's break down the information we're given in the problem and set up an equation. X, the value we're trying to find, is how many total video games Max has in his collection. We know that if we subtract 5 from x and multiply it by 6, it is equal to 3 times the amount of x plus 75. So while there are a lot of numbers to break down, setting up the equation is fairly easy once you know what x is representing. Like any equation, we want to simplify, combine like terms, and isolate the variable. Let's start with distributing the 6. 6 times x is 6x, and 6 times 5 is 30. So now we have 6x minus 30 equals 3x plus 75. Now subtract 3x from each side and we have 3x minus 30 equals 75. Add 30 to each side and we have 3x equals 105. Divide each side by 3 so we can get x on its own. We're left with x equals 35, and that's our answer.